All right, now that we have learned how to take the derivatives of exponential functions, we are going to learn how to take the derivatives of logarithmic functions here in section 4.5. So if we are given f of x equals log base a of x, and as long as a is not equal to 10, so if a is equal to 10, this is our basic logarithmic function, and it's going to have special rules and everything. So if it's not equal to 10, then our derivative f prime of x is equal to 1 over the natural log of our base a times x. If we're given f of x equals ln of x, then f prime of x is equal to 1 over x. So the difference there is if it's base e, ln of e cancels out and leaves us with 1 over x. If we're given log of g of x, so a composite function here, this is 1 over ln of our base of 10 of g of x, or times g of x, and then times g prime of x, presuming that the base on the log is 10. Note, all of our rules for logs still apply. Sometimes we will use some logarithmic rules in order to simplify our derivative. It's just easier that way. You could do it the long way based off of what's given, but in those senses, we can just simply use log rules to make it a lot easier. So we're told, find f prime of x for the following. So for the first one here, f of x equals the natural log of 8x. So by our definition, f prime of x for natural log is 1 over x. So it's going to be 1 over 8x times the derivative of our inside. So the derivative of 8x is 8. So we get 8 over 8x, which then reduces back down to 1 over x. Even though we have a multiplier inside of our natural log, as long as there's nothing added, subtracted, x isn't raised to a power, it's going to simplify back down to 1 over x. We just have to make sure we understand the steps to be able to get there. For our next case, the natural log of the square root of 2x plus 1, we could make this the natural log of 2x plus 1 raised to the 1/2. By log rules, so just so we don't have to use the chain rule, this would be 1/2 natural log of 2x plus 1. So then taking its derivative now, this is 1/2 times 1 over 2x plus 1 times 2 by our quote chain rule there. So simplifying this, we get 1 over 2x plus 1 because this 2 and this 2 cancel each other out. So if we go back up here and we think about what it says, log base a, its derivative is 1 over ln of a times x. So we now have one that's not base 10. So f prime of x is equal to 1 over the natural log of our base of 5 times our 6x. Then this whole thing is times the derivative of 6x, which is 6. So this is going to give us 1 over the natural log of 5 times 6. Oh, sorry, not times 6, times x, because the 6's cancel each other out. We can also have quotient rules here, like we're seeing here. So this derivative, f prime of x, is low times the derivative of the high minus the high times the derivative of ln of x, which is 1 over x, all over ln of x all squared. If we simplify this, we get 6x ln x minus 3x all over ln of x all squared. Not a whole lot we could do with this. We could factor out a 3x if we wanted to make this 2 ln x minus 1 all over ln of x all squared, but that's about the only thing that we could do. We do want to make sure we're getting in the habit of simplifying our derivatives because we're fixing to be making it to stuff where it's our first step, not our last step. So in this case right here, f of x equals the natural log of x plus 4 times x squared plus 5. And this one would be a good case that you could either multiply these out or use log rules. I prefer log rules because they help us out a lot easier. So this would be the natural log of x plus 4 plus the natural log of x squared plus 5. This is our f of x. So then our f prime of x is 1 over x plus 4 plus 1 over x squared plus 5 times 2x. So we get 1 over x plus 4 plus 2x over x squared plus 5. That would be our derivative. No need to worry about putting them into one fraction. You can leave it just like that at this point, and no worries. So, example. F of x equals the natural log of x plus 1 all raised to the 4th. Is this f of x equals ln of x plus 1 all raised to the 4th the same as f of x equals ln of x plus 1 to the 4th? Well, let's think about that. So if we took their derivatives to see if their derivatives are equal, because that would tell us if their functions are equal. So the derivative here is 4 times ln of x plus 1 to the 3rd times 1 over x plus 1. So in other words, 4 ln x plus 1 raised to the 3rd over x plus 1. But the derivative here, well, first let's rewrite this as 4 ln x plus 1. So its derivative is 4 over x plus 1. These two are not equal. They are not the same because in the second case here, ln of x plus 1 to the 4th, only the x plus 1 is raised to the 4th. But way back over here, our entire function of ln is raised to the 4th. So there's a difference in seeing when they're equal and when they're not equal here. So for this derivative, f prime of x, this is for the function 3x plus 1 times ln x minus 1. It's a product rule, product of the first and the second. So the derivative of the first one is 3 times the original of the second one, plus the original of the first one, times the derivative of the second one, which is 1 over x minus 1. If we wanted to get a common denominator here, we could, to make this, if we multiply everything by x minus 1, 3 times x minus 1 times the natural log of x minus 1. Be careful not to multiply inside that ln. That's an argument about ln, not a multiplier, so you don't multiply that. And then plus 3x plus 1 all over x minus 1. So be careful on that you don't try and do that. Because all we did was we took this term and multiply by the quantity x minus 1. So this next one we're looking where it has a horizontal tangent line. So if we have f of x equals natural log of x over 4x, we're going to need its derivative. So f prime of x is equal to low times the derivative of the top, which is 1 over x, minus the top times the derivative of the bottom, all over the bottom squared. So we get 4 minus 4 ln x over 16x squared. Horizontal means we set it equal to 0 and solve. Means I don't care about the denominator. I really only care about 4 minus 4 ln x equals 0. 4 equals 4 ln x. 1 equals the natural log of x. Taking e to both sides, e equals x. We took e to both sides because e and ln are inverse functions and therefore cancel each other out. So that's why we can do that. So therefore, to answer this problem, find where fx is a horizontal tangent line. It is only at the value of x equals e, or approximately 2.71828.